Okay. Well, thanks everybody for being here. Welcome. My name is Jeff Bartley, and I'm a product manager on the AWS DataSync team, and I'm joined today by Eric Durand, who's a product manager on the Snow Family team. And we're excited to talk to you today about how these services can help you with both online and offline data movement. So just from a quick agenda perspective, we'll start with an introduction into kind of some of the services that AWS provides around migration, data movement, as well as just some concepts around data, moving data, and things like that. Then I'll talk about AWS DataSync, give an overview of that service, and then I'll turn it over to Eric. He'll talk about the Snow family of services, and then he'll also talk about ways that you can use DataSync and Snow together, particularly as part of your migrations. And then he'll do a wrap-up, and we'll call it there. So this number shouldn't really be surprising to many of you. There is a lot of data out there. There's things just generating massive amounts of data for all kinds of processes. So much of it is automated. And if you manage storage or if you manage data at all, you're probably in the situation that a lot of the customers I talk to are in, where they're like, I don't know who owns this data. I don't even know where it's coming from half the time. I don't know what to do with it. A lot of it's cold, but I have to do something with it because I have to hold on to it and I can't just arbitrarily delete it. So this data just continues to pile up, and our customers are coming to us and asking, I need something to do with it because I've got finite capacity on premises, et cetera. So there's a couple of key business drivers that are kind of our customers are focused around when they're thinking about moving their data into AWS. So the first of these is like retention and compliance. And maybe you're in this situation where, for various needs, you may need to hold on to data for years. Some of our customers, it's 7 years, 10 years, or even longer. It's cold data. Nobody's probably going to touch it, but they just have to meet their compliance needs. And so they need to move this data, and they're looking for, ideally a low-cost place to land it. And things like S3, Glacier Deep Archive are a good place for that. Business continuity is another one where, these customers, maybe they don't want to move their data out of their on-premises environment, but they need a second place for it to land. Maybe it's for disaster recovery purposes. Maybe they just need that second copy. Cost reduction is always a big thing. Like I said, there's lots of data out there, and looking for ways to reduce the cost of storing that data, another driver for them. And then capacity and growth. As this data continues to pile up, you've got storage systems on premises that have finite capacity, and so customers are just looking for ways to deal with that capacity, deal with that growth, and a lot of the times that means moving that data off of those primary systems and maybe into the cloud. So these are just some of the things that are driving our customers to consider data movement into AWS. Now, if you've ever had the challenge of migrating or moving a lot of data, you probably know that it can be pretty challenging. I've done a lot of these in the past with customers where they went down a path of, hey, I'm going to do it myself. I'm pretty comfortable with this. I can write some scripts and I can do this. And they quickly discover, particularly at scale, how challenging that can be. You have to think things about like around security. Are you going to encrypt your data as it's being moved? How do I think about verifying my data? That's a big one. I've worked with customers in the past where they don't have a verification of their data or a plan for verifying their data. It's like, I'm just going to spot check. Yeah, this file moved here, this file moved there. It's probably good. Well, that's maybe you can do that when you have thousands or tens of thousands of files, but when you're talking about millions or even billions of files, that's not going to work. You want to know that your data landed safely. Things like recovering from errors. Maybe you've had this situation where you're doing a data migration and you realize halfway through, oh man, I'm not copying the data correctly. I didn't set that one flag correctly and the metadata didn't get copied or something like that, right? It's a real nightmare and you have to start all over again from scratch. So recovering from those errors can be challenging. Things like handling network availability, making sure you don't swallow up all your networking, or vice versa, making sure you're getting the performance you need to hit your data migration or data movement targets. So these are all some of the challenges that our customers have dealt with and have come to us and said, hey, is there an easier way? And so at AWS, we've worked on building out services to help our customers address some of these challenges. Services like DataSync and Snow Family, which are focused on helping our customers move data online and offline, files and objects. And we've got other services like Application Migration Service, which helps customers migrate their virtual machines, their servers onto EC2. And then Database Migration Service, which is focused on helping customers with SQL workloads and things like that, getting them into the various database capabilities that AWS provides. So a number of services out there to help our customers. Of course, today we're going to focus on DataSync and Snow Family. So with that, let me jump into DataSync and talk a little bit about the service and what it does. So DataSync was really built to help our customers address a lot of those large-scale data migration and data movement challenges that I mentioned earlier. So DataSync is designed, it uses, underneath the hood, we have a custom protocol that we wrote to help accelerate the movement of data over networks. It uses parallel streams to transfer data very quickly, achieve high levels of throughput, and maximize network bandwidth for our customers. So really get that fast movement of data. Security is critical to us here at AWS, so DataSync has built-in encryption both in flight and at rest. And we have byte-for-byte verification both in flight and at rest, so customers can be sure that that data movement was moved securely. And we recently launched capabilities around reports where you can get checksums on all of the data that was transferred. So we can give customers that feeling that, yes, my data was actually transferred not only securely, but I'm sure that it made it there when it needed to be. It's a fully managed service, so we take care of a lot of things around connecting into common services like CloudTrail and CloudWatch. And then we also take care of connectivity into AWS storage services, which, things like S3, Amazon FSx, and EFS, which sometimes setting up the connectivity to those, particularly the file systems, can be a little bit tricky. And so our service takes care of that for you. And finally, we're trying to make it as easy to use as possible, minimize the setup time. So with DataSync, we have a lot of built-in capabilities around scheduling, filtering, and other capabilities to help you move your data faster and easier. Now, our customers are using DataSync primarily for 4 use cases. And the first of these is really accelerating their recurring data transfer workflows. And a good example that I like to use for this is like with genomics. I work with a lot of customers in the life sciences industry where they'll have instruments on premises, so like customers doing genome sequencing. These systems are generating potentially terabytes of data per day, and these customers are looking for ways to bring that data into AWS because a lot of times these are like startups and they don't have the compute capacity on premises to be able to deal with that data, but they're generating a lot of it and they need to get it up into the cloud somehow. And so they're using DataSync as kind of this ongoing data transfer of this data as it gets created off of the jobs that are running on the machines, lands in local storage, and then DataSync is copying it up quickly up into the cloud. And then we have like event-driven capabilities through CloudWatch that can trigger their downstream processing. So accelerating those kind of recurring workflows. The second is migration. So customers have applications that they're looking to bring into AWS. Those applications typically have some kind of shared file system with storing data associated with that application. Maybe it's an object store or something like that. So as they're bringing those applications up into AWS, they also need to bring that data, and DataSync is there to help them with those file system or object storage migrations into AWS. I mentioned business continuity as one of the drivers for moving data. So customers can use DataSync scheduling capabilities to make ongoing replications of data into AWS. So I've got a bunch of customers who just set it up on a schedule, hourly, daily, weekly, whatever their recurrence is, to be able to make a second copy of their file systems, their data up in the cloud. And then finally, archive. A lot of the data out there is cold, as I mentioned, and so our customers are looking for ways to free up their on-premises capacity, and they'll use DataSync to copy directly into something like Glacier Deep Archive, free up that on-premises capacity and use it for other purposes. So kind of taking that cold data off of their expensive on-premises storage and move it into the cloud. So what are some of the things that you can do with DataSync? I've kind of referenced them, but we'll dive a little bit deeper here. So the first of these is really using DataSync to move data to and from on-premises and the edge. And I see that to and from. That's an important thing to understand with DataSync. We're not just focused on moving data into AWS. We have customers who are using data to move outside of AWS as well. DataSync supports both of those. So for on-premises storage, we can work with really, NAS servers, anything that talks the NFS or SMB protocol, which are common NAS protocols. We also support object storage systems that are compatible with the S3 API. And you can also use this with copying data from Hadoop clusters. And I'll talk here in a little bit about a customer who used DataSync as part of their Hadoop migration. We also, DataSync can work at the edge as well. So AWS Snow Cone is a small form factor ruggedized mobile device. Eric will talk about that a little bit more here, but every Snow Cone device comes built in with the DataSync software on it. So what customers can do is they can load data onto these small devices, bring them back to the office, bring them back to their data center, plug it into the network, and then use DataSync to copy from the device up into AWS. You can also use DataSync if you've got Outposts or something like that and you're storing data in S3 on Outpost. DataSync also works there as well. And then we can move data into AWS. Those are the three storage systems that we support. S3, any storage class, FSX file systems, all the file system types that they offer, or EFS. So we've also got customers who find themselves inevitably in some kind of multi-cloud situation for one reason or another. And this could be because they've acquired another organization that is running in another cloud different from AWS. It might be that they have some users within their organization that are storing data in a different cloud and they need to move it into AWS. But regardless of the reason, operating in multi-cloud environments can get complicated. And AWS has been building up services over the last few years to help our customers address some of these multi-cloud challenges, and DataSync is one of those. So last year, we launched support for copying data to and from Google Cloud Storage and Azure Files. Earlier this year, we launched support for Azure Blob Storage, and then just a few months ago, we launched support for a variety of these other clouds. They're S3 compatible object storage. So you can use DataSync not only to copy data from these other clouds into any of these AWS storage systems, but also from AWS into other clouds if needed. So enabling our customers who are operating in kind of these multi-cloud type environments. And then finally, our customers are using DataSync to move data between AWS storage systems. Maybe they're making a copy of some data in one S3 bucket to another. They're going from EFS into S3. Any combination of these, DataSync can support. It's intelligent about how it moves data and metadata. It tries to do the right translations between those to ensure that the data lands in a way that it's usable at the other end. And so the cool thing about this is there's no infrastructure to deploy or manage. You can copy between any of these storage services. You can also use DataSync to copy within the same region or across regions. And the nice thing about this is that all traffic stays within the AWS network. It never leaves the network. It doesn't go out to the internet and back or something like that. Always within the AWS network. And all traffic is encrypted using TLS 1.3, exactly the same as if you're copying from on-premises or other clouds. All traffic is encrypted in flight using TLS. So let's talk a little bit how DataSync works. So if you're copying from on-premises or edge locations or maybe from other clouds, the first thing you're going to do is you're going to deploy a DataSync agent. And a DataSync agent is simply a virtual machine that you deploy in like a VMware, Hyper-V, KVM environment. It also can be deployed on EC2. So there are certain cases where you may want to run the agent directly on an EC2 instance running in AWS, but it just really depends on your use case. And then you create storage locations. So a location is just a location resource that DataSync has that tells DataSync how to connect to your storage. That's like the IP address, the server name, credentials for authentication, things like that. And then you run a task, and the DataSync service takes care of moving data from the source location to the destination location taking care of all the different combinations of data, metadata, things like that, and the configurations that you've given us. And if you're copying from on-premises, we have a variety of networking type capabilities that we offer. We support internet, copying over the internet. You can use Direct Connect, or you can also use site-to-site VPN. Regardless, again, all traffic is encrypted in flight using TLS 1.3. So I referenced a customer earlier. Globe Telecom is a large telecom provider based out of the Philippines. They do landline, mobile, and business type telecommunications, and they serve over 60 million customers in the Philippines. And a lot of their services and support and capabilities that they provide to their customers runs on AWS. And Globe had this challenge. They had a Hadoop cluster on premises in their data center. It had about over 7 petabytes of data on it, over 1 billion files. And it was running on Cloudera. And their Cloudera license was coming up for renewal. The system was running out of capacity, and the customer said, well, you know what? We don't want to renew. We don't want to build out more capacity. We're trying to move more of our data into the cloud. Let's get this thing migrated. And it happened to be that they had a direct connect from their data center in the Philippines into one of the local regions. I believe it was Singapore. And the customer said, we want to do this over the network. They explored a couple of different options, and they ultimately landed on DataSync to help them with us. Now, they needed to do this in 4 months because they had calculated, within 4 months, we're going to reach the end of our capacity in this Cloudera system, and we got to do it before then, and also before that license comes up for renewal. So they started using DataSync, and they were quickly able to scale it up to the point where they were achieving about 72 terabytes a day. That's roughly about 800 megabytes per second, maximizing out their bandwidth. They had to share it with a few other services, but reaching about 85% of that 10 gig direct connect line. They were able to move their data within their period of time that they had, all 7 petabytes, 1 billion files. Great success story using DataSync. If you want to learn more, that QR code links to a blog that talks about how Globe Telecom set this up and executed it using DataSync. So a great resource to check out. And with that, I'm going to turn it over to Eric, who's going to talk about Snow Family.
Excuse me. Hi, I'm Eric. I'm a product manager from the Snow Family, and I'm going to talk to you a little bit about what the Snow Family service is and how it can be used for performing data migrations primarily offline. So what is the Snow Family? The Snow Family enables you to move petabytes of data to and from AWS, or if applicable, you can also process that data at the edge to optimize for the amount of data that needs to be transferred. And so the Snow Family comes in different physical devices with different built-in compute and storage capacities. So for smaller data transfers, say of less than a terabyte, you can use a smaller AWS Snow Cone device. And then if you can ramp into even tens of petabytes of data migration using clusters of larger Snowball Edge devices. And AWS Snow Family devices are all owned and managed by AWS. So there's no hardware for you to purchase. This is something you just go in and order from the console. And these are, as they're owned and managed by AWS, they integrate with AWS security, monitoring, and storage management and computing capabilities. And so Snow Family devices provide a set of capabilities on the partially connected or even fully disconnected edge, meaning you need to, in an environment where you have no access to a network or not to a reliable network, you can transfer your data to the Snow devices or perform data collection at the edge, perhaps collecting telemetry data or migrating archival data without having to impact the bandwidth that's available to you. And you can perform data processing on that data at the edge, again, to optimize for the amount of data that you need to send back to the region or just shipping back the high-value data to the region. So the Snow Family provides edge hardware and software that enable that data processing and analysis to close to where the data is being generated. Again, so that without concerns about bandwidth or connectivity, you can collect that data wherever it needs to be, whether that's migrating from a data center, collecting that data from, say, an oil rig, whether it's in a vehicle. It opens up a lot of different possibilities for where you can collect data that ultimately needs to come back to the AWS region. So there are two purposes for the Snow Family service that customers use it for. Originally, we started as an offline data movement business, and that's still a big part of what we do today for customers, and that's what I'm going to talk about primarily today. And that's where we provide secure and fast data collection, processing, and then ultimately shipping back large volumes of data back to the region. The other use for the service that we won't spend too much time on is for rugged edge computing. And so this is where we actually bring AWS services that you're familiar with in the region and bring a select set of them that are available to be run on premises or at whatever edge location you have with no dependency on any network connectivity. We can run in a fully disconnected or partially connected environment with a set of compatible APIs for services that you use in region. So, as I mentioned, the chief key value proposition and the original key value proposition for AWS Snow Family was for offline data movement, and really can scale to any size data migration, whether that's, again, terabytes or tens of petabytes. But as Jeff mentioned with DataSync at AWS, right, security is incredibly important to us. And so to ensure your data is secure, we take a number of steps on the Snow device. The Snow devices are purpose-built, and they have tamper-resistant and tamper-evident enclosures, whether that's a snow cone or a Snowball Edge device. And all data that's written to the device is written with and stored with 256-bit encryption that is managed through the AWS key management system through keys that you own and manage. And those keys are never stored on the device to ensure security. So in the event when this device is being physically shipped, there's no ability for a bad actor to be able to compromise your data. And finally, the device has what's in it called a trusted platform module. And so this is a chip that's specially designed to determine or to tell us if there's been any sort of physical compromise to the device, whether that's firmware, hardware, and the like. And when we receive the device, we have a secure inspection process where we go through and ensure that the device itself hasn't been compromised in any way before we connect it to the region and import the data into your buckets. And then, as I mentioned before, this really can scale to any size data migration, right? So you can use clusters of these devices to store tens of petabytes of data locally at your edge location, whether that's in your data center or at some other remote site, and then ultimately ship that data back to AWS. And we offer compute services and cloud capabilities at the edge. So with fully compatible APIs for services like EC2, EBS, S3, Identity Access Management, IAM, which is actually run locally on the Snow device, IoT services, as well as Lambda, to really give you a great deal of flexibility in terms of the types of ways that you can collect and manage your data at the edge. So let me talk a little bit about the two form factors for the device. So this is the AWS Snowball Edge. This is roughly a suitcase-sized device. If you go to the expo floor, you can see various versions of these devices that are on display. And these come in different capacities. And so there's a compute-optimized version of this appliance, and there's a storage-optimized version. So the compute-optimized comes in 3 different varieties, either with 32 virtual CPUs, 52 virtual CPUs, or our latest generation comes with 104 virtual CPUs. And there's a commensurate amount of RAM for each one of those models. So if you think with 4 gigs of RAM per vCPU, scales up to, at the 104 vCPU model, 416 gigs of RAM. The compute-optimized device comes with 28 terabytes of all NVMe storage to ensure that you have fast processing for your data, highly performant storage. And our newest storage-optimized version has 210 terabytes of all NVMe SSD storage available on the device. And the devices support up to 100 gig networking connectivity, so 1 gig, 10 gig, or 100 gig, depending on what the environment requirements are. And as I mentioned, every device is fully tamper-resistant and tamper-evident in this custom-built device. And as you can see, there's an e-ink display. That actually is the shipping label for the device there in the center. That also services as the touchscreen interface for when you initially configure the device. In the lines of security, as I mentioned, all data is secured, is written to the device and secured with 256-bit encryption for keys that you manage and own that are never stored on the device. And while maintaining that security, the device has also been designed to be operated by non-technical personnel, because as we have many customers sending these devices to all sorts of remote locations, there might be, not an IT administrator available at that site, so we have to have a simple graphical user interface for them to perform that data collection and in order to perform the data collection and migration back to the region. The other chief piece about these devices is they're designed to be rugged in addition to being secure. And so the device has been designed to handle up to 200 Gs of impact on the Snowball Edge. It's airdroppable. There's lots of fun videos you can find online. And it does meet various military and US federal standards for ruggedization, as these are used widely in public sector type customer environments. It's also been designed to operate in austere environments, so it can operate with unconditioned power and in environments anywhere from 0 degrees to 45 degrees Celsius. And of course, in the case of a data migration, you might likely be bringing that from a data center. You can connect this in your data center as well. And then weighing in at 49 pounds, it's been designed to be able to be carried by a single person. The snow cone is the other variety of this device. And so this is a smaller, much smaller, ultra-portable device. This is roughly, say, the size of a tissue box. And it also has a custom-built, it's a custom-built device designed to be tamper-resistant and tamper-evident with the same processes that we manage the Snowball Edge device. All data is also secured with 256-bit encryption, and it can use that same management system, which I'll talk about later, called Ops Hub, to be operated by non-technical personnel. It's also rugged and can handle vibration up to 50 G RMS, and can operate in the same austere, austere environments on unconditioned power, anywhere from 0 to 45 degrees Celsius. And weighing it at just 4 pounds, it can be put in all sorts of places. So we have customers using these things in vehicles for data collection, aircraft, mining rigs. If you actually looked up, one of these is actually on the International Space Station and is being used by our partner Axiom and NASA for certain applications actually out in space. But it doesn't have to go there. It can just be thrown in a backpack and really taken to wherever you need. So as I mentioned, there are a number of services that are available to be run locally in a disconnected fashion on Snow Family devices. And so what's exciting to call out here is it's really just it's an extension of the AWS region where you get a select set of these services available to you at sites where there isn't an AWS region or you don't have a connectivity to that region. These are things like AWS IoT services, storage services, machine learning, compute, and containers that enable you to run a wide variety of workloads on the device. So this wheel represents the services that are available. So for compute, we support a EC2 compatible API. We also enable you to run Lambdas through the use of IoT Greengrass, so you can run serverless applications on the devices. And then finally, you can run container-based applications using EKS Anywhere on Snow. For IoT and machine learning, we offer IoT Sitewise Edge, as well as SageMaker Edge, and AWS IoT Greengrass version 2 is available on the Snow devices. And then finally, for things like security, storage, and data transfer, we support local identity access management, IAM. We support DataSync for data transfer, as Jeff alluded to earlier. And for storage, we have S3 compatible APIs, EBS compatible APIs, and also local NFS storage, depending on what type of storage you need to get on the device. So you have a lot of options. And then all of these are just really designed, so you don't need to use all these capabilities, but you have a great deal of flexibility in the types of use cases and workloads that you need to collect and get data back to the region. So I mentioned these being simple to manage, so we accomplish that through Ops Hub. So of course, you can manage the device through a command line interface, script all sorts of configurations, and we have many, many customers do that. But we also have customers manage and monitor multiple Snow devices at the edge using Ops Hub. And so Ops Hub is just a simple graphical user interface, and all you need to do to use it is to download it to a local host, like a laptop, that's on the same local network as the AWS Snow device, so no connectivity to the region is required. And then what you're able to do is just simply, with a few clicks, you can connect to and then unlock your Snow device securely. And then that takes you into a dashboard where you can do all sorts of things to monitor the compute and storage resources on the device, as well as do things like launch EC2 Amazon machine images or AMIs that have been preloaded on the device when you ordered it. You can spin up containers, provision your volumes, and then you can also do things like online data transfer by spinning up DataSync on a Snow Cone device and initiate that transfer using Ops Hub. Here you can also drag and drop. You can initiate a NFS file transfer copy, which will actually allow you to drag and drop the files into the graphical user interface to copy them onto the device. So let me talk a little bit about how specifically you would use the Snow devices to perform an offline data migration. So this timeline here represents what the data migration workflow looks like when you're using the Snow service. And this goes from everything from device ordering to the device being provisioned, to when it's shipped, to when you're using it on site, and then when ultimately it's sent back to the region for data ingest into S3 or S3 storage classes. And so each stage of this process takes on average about 2 to 3 days, with the exception of when you're copying data onto the device, right? And that's represented by the variable n on the timeline there, given that that's dependent on a number of factors, like what is the overall size of the data set you're trying to migrate? What is that data set comprised of? Like, are there things like lots of small files that you need to take in consideration, which can take longer in a data transfer? What is the speed of your local host that you're copying from? What type of network do you have? But in that scenario of data copying, you can really use on average, let's say it takes about 30 days to accomplish a 500 terabyte data migration and about 60 days to accomplish a petabyte data migration. And we'll talk more about how to compare that online and offline and when you should use each. But there's also, I shouldn't call out that there is no SLA because of those dependencies on local infrastructure. So all these timelines I'm sharing are a rule of thumb that you can use for planning your migration. But given our dependencies on local environments, we don't offer an SLA. So what you do is you go to the AWS console and go into the Snow Family management console, and there you can order a device. So you specify the type of device that you need, whether that's a Snowball Edge, compute optimized, storage optimized, or Snow Cone, and then you submit that order. That's called a job when you submit that order, and it takes roughly 1 to 3 days, just depending on the region and other circumstances of inventory and the like, for that device to be provisioned. You also at that time specify things like what bucket are you going to be importing into, what are your encryption keys that you're managing through KMS that will be used for encrypting data on the device, and then also simple things like how fast of shipping do you want, right? We offer 1 or 2 days shipping, depending on what you want to pay for. And then the device will be shipped to you, again, at that shipping speed. And then once you receive the device, again, you can use Ops Hub or the command line interface to unlock and configure that device and begin migrating data onto the device. That data will then be copied, and then simply when you're done with the copy, you simply power down the Snow device, and that e-ink display that I mentioned earlier will update itself with the return shipping information automatically, and then it will be shipped back to AWS again at the shipping speed that you had specified, either 1 or 2 days. We receive it at the region in a secure room, we call it a Snow room, and in that environment, we do our tamper, we check to see if the device has been tampered with, and then we securely connect it to the region, and the data is then automatically copied into your S3 buckets using the security keys that you had being unencrypted and written to the bucket using the keys that you had specified. You then receive a notification that all of your data has been migrated, and then we perform a secure erasure on that device following NIST 800-88 standards, and we'll re-provision that device for the next customer. So I want to talk about a real-world example of a customer that had to perform a large data migration in a short amount of time and opted to use Snow for that data transfer. So Trellix is a global cybersecurity company, and they had a 2-month deadline to migrate 400 terabytes of data. But one of the challenges associated with that was not just the relatively short timeline, but it was also, that data was comprised of over 300 million files. So think lots of small files that they need to write. And when you're writing a lot of small files, that actually puts a lot of strain on the system and can significantly, just in general in storage, and can significantly impact the amount of time it takes to read and write that data from one storage system to another, like the Snowball. And so these proprietary threat files, these tiny little files, all needed to be met and in order to complete their effort of shutting down their data center and no longer incurring the operational costs of managing that data center. So the Trellix team performed an evaluation of various services, and they decided, working with their AWS team, that Snow was the best option for performing that data transfer. And under the advisement of their AWS account team, they also they enacted a script to bundle some of their small objects into larger objects to optimize the time that it would take to accomplish that transfer. And they also set up a number of parallel workstations so that they could be copying that data. Once it was bundled, they could be copying that data in parallel to multiple Snowball Edge devices, specifically to 5 devices. They then migrated all of that data back successfully to AWS. Were able to accomplish that well in advance of their 2-month deadline, and were able to successfully shut down that data center and realize the associated cost savings. And so this quote from Trellix's distinguished engineer really says it all. I won't read the whole thing to you. I'll just give you the last part here. But he just said that, well, that's tiny. But we were impressed by the ease of use of AWS's programmatic approach to meeting timelines. In the end, we avoided costly on-premises software, hardware, and network upgrade costs, and the Trellix Advanced Research Center exceeded the data center exit timeline and are back to running our business. And that's really what we want to hear, right? Your data migration is not your full-time job, most likely, so we want to make it as simple and as programmatic as possible to enable you to move on to your other tasks. And so in this vein, this is really the approach that we take with all of our customers trying to accomplish a large data migration, and AWS account teams are well-versed in this. And really central to this approach, which Trellix used and other customers like Photobox and Netflix have also used, is a proof of concept. So when you're evaluating the different storage services, different data transfer services available to you, which we'll talk more about, and you arrive at Snow, I highly recommend you perform a POC, a proof of concept, and this will allow you to do things to discover and remediate any environmental issues. Do you have limitations in bandwidth? Are there issues with the storage array or the servers that we're copying from? And to test and deploy how many staging workstations do you want, how many Snowball Edge devices or snow cones do you need at that site in parallel to perform this transfer? Do we have a lot of small files, or is any sort of modification needed in order to optimize that data transfer? And then ultimately just benchmark and optimize the data transfer so that you can set a predictable schedule for how long it will take to accomplish that data transfer with the right number of devices. So there are 2 QR codes on this slide. Those take you to white papers that have been written by AWS solutions architects that will give you best practices for accomplishing a data migration with Snow and with other services. So I mentioned briefly earlier that we had recently launched a new storage optimized device. I just wanted to call this out because this device was purpose-built for large-scale data migrations. So this is the new denser Snowball Edge storage optimized. It's available now. It comes with 104 vCPUs, along with 416 gigs of RAM, and that is paired with 210 terabytes of all NVMe SSD storage. So again, this device is, from the perspective of our other devices, a powerhouse that's designed to be able to run any number of applications. It supports all of those offline services that I mentioned earlier, the disconnected services. It supports new, larger EC2 instance types on the device, and of course, gives you all of that storage capacity so that either with a single device or with clusters of these devices, you can perform very large-scale, multi-petabyte data migrations. It does come in 2 different pricing options, monthly and 1 year, and you can find all that stuff online. So we also, earlier this year, launched a new version of the S3 compatible storage service on Snow. So we've always had what we call the S3 adapter. But what this service does is it provides a more robust version of S3 that's much more in line with the sort of experience you have with S3 in region. This S3 compatible storage on Snow allows you to deploy multi-mode S3 clusters anywhere from 3 to 16 Snowball Edge devices. So if you look at that, like on a denser Snowball Edge device, you can get to quite large on-premises storage pools. And then it's also been designed with improved durability and redundancy. So devices using S3 compatible, when stored on, or data when stored on using S3 compatible on a Snow device is written more durably across the number of disks on the device. And when we're in clusters, it's written more durably across the number of disks and number of devices in that cluster. And then all data, of course, is encrypted. And this, in the case of S3, it's with server-side encryption, either with S3 managed keys or with customer managed keys that, again, you can configure through KMS. And finally, it supports a number of local S3 bucket and object management features, things like event notifications, and that you can use to optimize the sort of data processing that you're doing when you're writing data to these devices on premise. Another feature we have available in the console for those of you looking at larger data migrations is the Snow Large Data Migration Manager. And so this tool allows you to plan, execute, and monitor your large data migration projects. And it's available in the console. It's suited for migration projects that are anywhere, say, from 500 terabytes to multiple petabytes of data that you want to migrate at one time from, again, an edge location or your data center into an AWS region. And what it does is it's a planning tool and a dashboarding tool for managing that migration. So you give it a couple of pieces of information when you're setting it up, and these are things you would find out when running that POC. So it's how much data, what is the overall data set you want to manage, and then what is the number of concurrent devices that you would support on site to perform that migration, say a number of storage optimized devices or a number of previous generation storage devices. And then what that will do is that will then allow you to automate the creation and the monitoring of the progress of each one of those jobs associated with each individual Snow device so that you can track the overall progress of the migration and get real-time status and insights into how you're completing that, how that migration is progressing, as well as then when the next set of jobs need to be ordered. Those will all be automatically configured and ready for you to provision. So it takes a lot of the project management work out of performing a multi-device migration. So I also want to talk a little bit, in the last piece here, on how you can use DataSync and Snow together, but also before we get to that, when you should think about using online transfer with DataSync versus when you think about using offline transfer with Snow. So we do give you plenty of choices when you need to migrate your data, right? We're talking about two of those options today. Jeff mentioned some of the ones at the very beginning of others at the very beginning of the presentation. But when you're considering online versus offline, there's really two dimensions to consider. And the very first one that you want to think about is speed, right? So if speed is a critical factor in your migration, we recommend as a rule of thumb that you should proceed with online. Right? And the reason for that is when you think about data transfers, an online data transfer is measured in minutes or hours, and an offline data transfer is measured in days. Right? So if this is data you need to move quickly, you probably want to look at online first. You also want to look at online if you're making frequent updates to those data. So if this is constantly changing data, it's in a production data set, again, you can't have that data be down for a while and not available to you, so you should look to migrate that data online. For offline, though, if it's a one-time or maybe periodic migration where you have a large set of data, maybe say an archive data set or backups you're preserving for the long term, or just an unchanged data set of telemetry data or the like that you want to bring into the region for analysis, then you should consider offline. And that's really because the data can be static while it's in transit, and it might be a more efficient use of bandwidth and other resources just to perform that offline. And that leads me to the second consideration, which is what bandwidth is available to you. So online's great if you have sufficient bandwidth available. And you want to ensure, though, that you're not competing with other applications, production workloads, and the like for that bandwidth. What's great about DataSync when you're doing that online is that even if you're in a scenario where you might have a potential competition for bandwidth, you can use things like scheduling and throttling that Jeff mentioned and perform that data transfer using DataSync. However, as I mentioned, there's a lot of customers for Snow that their environments where there really is no bandwidth, right? They might be at a mining site or a forward deployed location for the military or all sorts of other environments where there's very limited or no connectivity available to them, but they still need to get valuable data ultimately back to the region. And so that's where Snow comes in. It's great at data collection, has no dependency on the network, and can get you large volumes back. The other piece about it is some customers, right, the likes of what I was talking about, Trellix, just wanted the predictability of the physical move. They didn't want to be concerned. They knew they had a limited amount of bandwidth. They just planned through and kind of set up their project. So that's oftentimes we see customers select the Snow service in that scenario. So to choose between DataSync and Snowball Edge, I'm going to give you some general guidelines, right? Ultimately, you should work with your account team to kind of determine what is the best path forward for your data transfer. But there are two considerations when you look at this initially. And so it's what is your available bandwidth, right? And that's represented across the vertical line across the top, and then, horizontal line across the top. And then what is the overall data set that you want to move, represented by the vertical axis. And so, as you can see, that translates down to, so roughly guidelines here in numbers of days it would take to accomplish this transfer. The area in yellow, right, is we can make a pretty clear case you should be using DataSync, and the areas in white, you would consider using Snow. And so, for example, if I had a 5 gigabit connection, 5 gigabit internet connection, and I had 500 terabytes of data to move, then it would take roughly 12 days to move that data using DataSync. If I were to accomplish that, if I want to do that same thing with Snow, it's going to take you about 30 days, right? So in this scenario, it makes a lot of sense to go ahead and use DataSync. Now, if I had, say, 1 gigabit connection, and I had a petabyte of data to move, then it would take me 116 days to move that data using DataSync, where I could accomplish that same migration in about 60 days using Snow. So in that scenario, I probably want to opt to use Snow. And it's not all black and white. There's not a hard and fast rule. These are general guidelines. However, that's kind of what we're calling out there, if you will, in the gray area between the white and the yellow. And that's where, again, you want to take in those additional considerations. If you want to consider offline with Snow, if you just know that there's bandwidth limitations, concerns about bandwidth, lack of bandwidth, and you have a flexible timeline, right? Again, measured in days. You can take your time to perform the migration. For DataSync, you have plenty of available bandwidth. You have the ability to control the use of that bandwidth. And most importantly, you're under a strict timeline. Again, time critical, go online, go with DataSync. And we have some customers that actually use the two services together to accomplish large migrations. And in this scenario, what we've seen these customers do is they perform the initial transfer. They segment their data. They segment their data and look at what are the more static data sets that need to be migrated as part of this one-time large migration, and then what are the more dynamic data sets. And they perform the initial data transfer with that bulk data, right? That not impacting their bandwidth. They can accomplish that in days. They have a bit more flexibility around getting that data up into the region. And then they use DataSync to perform incremental data transfers for any of that change data sets, any of the deltas. Once the data transfer has been completed by the Snow device, they go into that incremental data transfer and then are able to complete the entire migration with both services successfully. So just to wrap up, a few key takeaways. So again, work with your AWS account team, get their advice in terms of what are the goals and what resources you have available to you for your cloud data migration strategy. And really look at your data set with their help. Look at your data set to separate what is your archival data and what is your production data, and which one of those can be accomplished best between working online or offline. Archival, offline, right? Production, dynamic data, go online. And then again, there's a number of tools like the Large Data Migration Manager, working with your account team to evaluate things like DataSync, and they can help you really come up with what is the best plan for migrating that data. If you'd like to get started with either service, these QR codes will take you to getting started with DataSync or getting started with Snow. And we encourage you to continue your AWS storage learning. You can take a learning plan in AWS Skill Builder. You can increase your knowledge using ramp-up guides, and that will lead you to earning AWS storage badges. All of these resources can be found at that URL, aws.training/storage. And also, if you want to continue to learn more about data migration and the various options available to you, there's 3 sessions left this week. There's a Chalk Talk later today. And then there's a builder session and a breakout session, I believe both tomorrow, on this very topic. So please join those sessions. And on behalf of Jeff and I'd like to say thanks. Thank you for your time.